Hello, everybody. Welcome to DK Classroom. Today we will introduce the product description and basic operation of the DT50W16. First, let's explain the structure of the machine. Fist the air inlet. There are two rows of channel indicators. The upper row is the run, stop indicator. The lower row is the charge, discharge indicator. Below are the channel output ports, which connect the output lines. This is the switch. This is 220V power socket. This is LAN port. This is the work indicator of the machine. Fist the LAN port. There are 4 air outlets on the back. Please keep enough space. Do not block the air outlets. This machine can test various types of lithium batteries such as 18650, 26650, 32650, pouch batteries, prismatic batteries, lithium iron phosphate, lithium ternary battery and other types of lithium batteries. 16-channel fully isolated design. Each channel is equipped with an independent high-efficiency processor, which can directly test the cells of the entire battery pack without disassembly, perform charge and discharge balance maintenance on the battery pack, and accurately locate the fault batteries. PC online test. The test data is particular and plentiful. Open the software installation package. The first step is to select the installation location. Some system does not have an installation location selection, then the default installation is disk D. Do not choose the disk C as the installation location. If you install to the disk C, the work step cannot be added in the next operation. If you install it on the C disk, you need to use the administrator mode to start the software, but for simplicity and convenience, please do not install on the disk C. After selecting the installation location, click Next to start the installation. Launch the software after installation is completed. In the initial running, if your network firewall is turned on normally, then the network selection will come out. Please check the public network to allow the program to pass through the firewall. If this public network is not selected, it may show connecting all the time when connecting to the machine. Then you need to turn off the public network firewall, or reset this program to pass the public network firewall. Below we explain the connection between the machine and the software. Connect the machine and the computer with the network cable. If you bought more than one machine, you can connect through a switch. When more than one machine is connected to one computer, the address at the back must be moved to a different number. If it is a whole set of testing cabinets, it has been set before leaving the factory. Then we turn on the machine, and after the initial flashing of the indicator light on the machine, it finally shows that the red lights in upper row are keeping on. Click the Connect button on the software. Click the Network Search button. Normally a device name will appear. If it does not appear, first check if your local network is enabled. If it shows that the network cable is unplugged, then the network cable is not plugged in properly, or try to replace the network cable. If your computer and the machine are not connected to broadband through a switch, then it is normal to display an unrecognized network. If it shows that the network is not connected, click the network search and no device name appears, then restart the software or restart the machine to try. If you can connect before, but someday you cannot connect, then you need to change the local connection IP address or reinstall the software. Click the network to search. After the device name appears below, select the device. Click to connect, an IP selection window will appear. You can directly default without modifying it. If there are more than one machine, the IP cannot be the same, and then click OK to confirm. It shows connecting and it will show online in a few seconds. If the connecting is always shown here, you will need to change the firewall settings, as explained earlier in the installation. After the device is connected, the device number is displayed here. Double-click the device number to view the information of the machine. There is a testing cabinet number here. If there are only a few units, then you don't need to change it here after you change the address on the back of the machine. If you have bought more than one testing cabinet, then enter the corresponding cabinet number here to avoid confusion. Here is the channel information. You can choose list display or card display. DK specified software cannot only support one computer to connect multiple devices, but also support one computer to manage different models of devices. The background color at the top of the channel information represents the corresponding device model you are currently connected to. The device supports all states to be displayed in the form of color blocks, and the colors can be customized, which is convenient for users to understand the current running state or find the test channel of abnormal state. In the upper right corner, there are work step settings, matching settings, and analysis buttons. The corresponding functions will be described in detail later. Below we explain the setup and precautions of the work steps. Click the Step button in the upper left corner of the software. The Step Setting interface appears. There are different models at the top of the Step Setting interface. First select the equipment model, and set up a work step program under the corresponding model. On the right is the name of the work step program. Click New Program to create the work step program. Input a name such as Cattle 2500 mAh. This program name is convenient for query in memory by yourself. The left side shows the step under this program. Right-click the program name can be renamed or deleted. After the work program is established, click to add the corresponding work steps under this program. Here you can see different steps in the drop-down box. You can select the step type according to your needs, fill in the relevant parameters, and click Confirm to create a step. Selecting this step and clicking at it can reset the parameters of this step. The up and down buttons can move the sequence of the step. The delete button can delete the step. The following explains the general sequence of testing steps for lithium batteries. First step, charging. Lithium batteries are charged at constant current and constant voltage. The parameters here: constant voltage, constant current, cutoff current, we must fill in. Time and capacity do not need to fill in, because these two values are the values we need to get in the test. If you want to fill in, do not fill in a value less than the actual value. This value means that the step will switch after running for this time or accumulating so much capacity. If it is filled in a smaller value, it will end this step early, resulting in inaccurate test results. The maximum value of the capacity can only be set to 65 Ah here. If this capacity value is not filled, the capacity can be accumulated up all along, and the capacity exceeding 100 Ah is also possible. Please check the unit of the corresponding parameter. Do not fill in decimal points or letters when filling in. First, the constant voltage input, nominal 3.7 V cell. The constant voltage is 4200 mV. Nominal 3.2 V cell is 3650 mV. The constant current is generally 0.5 C. C is the discharge rate. If you don't know the discharge rate, you can check it on the internet. Like the cells we tested here are 2500 mAh, your 0.5 C is 1250 mA, you can slightly round up or down. The maximum current of this machine is 10A. If you need to test a large cell with a current greater than 10A, we recommend to purchase DT2020 or DT5050. Then limited current, generally at 0.02 C. So for a 2500 mAh cell, the limited current is 50 mA. But if the limited current calculated by the battery capacity is less than 50, then don't fill in a value less than 50. Here, the minimum value can only be set to 50. If the calculated limited current is greater than 50, then fill in the actual value. It's okay to fill in a larger limited current here, but the measured capacity value will be smaller. If the limited current here is set to smaller, it will be judged to be abnormal. It'll happen this work step can't be finished. The software shows that it is charging all the time, and the current is zero for a while, and then it jumps to several hundred mA. The problem in this case is that the battery charging current cannot be as small as this value, causing the software to fail to judge properly. If you are testing the used cell, the cutoff current needs to be set to 2-4 times of the standard. Of course, you can also fill it according to the standard current. If charging cannot be stopped, you can determine that it's a fault cell. In addition, if testing a used cell, you can set a reasonable time limit. Prevent the battery from being charged all the time, causing an accident risk. Second step, discharging. Constant current discharge is generally used to measure capacity. You can also use constant power and constant resistance discharge. It is to set a fixed power value, or fill in the value of the analog resistance to simulate the discharge status in actual use. For the parameters here, you only need to set the cutoff voltage and constant current, and the discharge will stop when the cutoff voltage is reached, so there is no need to worry about the problem of continuous discharge, unless your cut 0 FF voltage is set wrong. The setting of cutoff voltage. For 3.7 V cell, cutoff voltage is 2750 mV, and for 3.2 V cell, the cutoff voltage is 2500 mV. The constant current can be the same as charging, usually between 0.5 C and 1 C. Between charge and discharge need to add a idle step. Idle means stopping for a few minutes. The function of idle is relatively important. First, to add the idle step after the charging or discharging, the final test result can get an internal resistance value. We will talk about this later in the data analysis. Second, the idle allows the battery voltage and temperature to return to normal values, making the test results more accurate. Third, to avoid battery damage caused by sudden conversion of battery charging and discharging, it also reduces the internal temperature of the machine and reduces the failure rate of the machine. The idle time is generally not less than 5 minutes. Below we talk about cycle step. If you are creating a new cycle step, there are two parameters. The initial parameters are all 0, and many users only change the cycle times, but the switch step number is not set. Then it will happen the step cannot be switched. This step number is the sequence number at front of the step. You can fill in the sequence number of the step you want to switch to. For example, there are 4 steps in front of this work program. If you want to do the charge and discharge cycle, you add the cycle in the 5th step, jump to the work step 1, and then fill in the cycle number. The system will automatically execute the charge and discharge cycles you fill in. The end of the step is best to end with charging, because it will damage the cells if the lithium cells are left unused after being discharged. If you add charging step after this type of cycle, and the cells don't need to be fully charged, you can set a certain period of time or a certain capacity to charge. Add stop step at the end of the work program. If you don't add it, the software will execute this step by default. But it's better to add it manually to stop working to avoid accidents. After all the steps have been set up, the saved data must be checked. If you do not check, the test data will not be saved. Then at least one of the following conditions needs to be checked. Mind checking time, fill in 10 seconds, not too short. Of course, it's also possible to check the voltage or current fill in the interval. This interval is to import a piece of data into the analysis according to the current or voltage change value, and finally we click Save. A new step program has been set. Click Export to export the work program to save. Click Import to import the saved work program to the system. Below we explain the matching settings. Matching means that the system judges the testing data according to the user-defined conditions and identifies the conforming and non-conforming channels. Avoid the heavy work of manual screening of cells and quickly screen cells that meet usage requirements. Click on the match in the upper left corner to open the matching setting interface. First, we set up a new matching program and fill in a name. We can add conditions under the matching program. The condition types include time, capacity, and voltage. Here we can add multiple conditions, but only one condition type data can be filled at a time, and do not fill in 2 or 3 types of data at the same time. Below we introduce how to fill in the conditions, taking this work program as an example. The number of cycles set for this work program is 3. If you need to filter the capacity of the last cycle discharge, then the corresponding cycle number is 3. If you want to filter the capacity of the first discharge, the cycle number is 0. In this work program, the sequence number of discharge step is 3, then fill in 3 in the step number, and fill in the capacity range below. Click Confirm, then one matching condition is set up. We can add more matching conditions as needed, such as adding a idle voltage after last cycle charge. The last cycle number is 3, the step number is 2, fill in the voltage range. Based on actual needs, here you can add the conditions of each cycle. After adding the conditions, for quick screening, you can also set the display mode of the indicator light to show the channels that comply with the set conditions. At last, click Save, and a new matching program is set up. The following explains the battery connection and work step start. There are 3 types of battery connection fixtures available depending on the batteries. Please choose one of them. If you need different types of battery fixtures, additional fixtures will need to be purchased separately. At the same time, we can also customize fixtures according to the special requirements of users. If this is a cylindrical cell like 18650, we use the probe holder to connect. Loosen the screws at both ends, adjust the height to a suitable height according to the size of the cell. Press the lower row of probes with the cell, put it in. It should not be too loose. After adjusting the height, refer to the scales on both sides to level the probes, then tighten the screws. Check if the upper shell and lower shell of the probe is in good contact with the cell. The pin in the middle of the probe is only for voltage sampling, and the shell of probe is for current. If only the middle pin is in contact and the shell is not in contact to the cell, there will be no current after startup. In this case, you need to adjust the height of the probe properly. If it is a pouch battery, etc., use a flat mouth clip to clamp it. Both sides of the clip must be in good contact. One side of the clip is connected to the sampling line, and the other is connected to the current line. If it is a prismatic battery, please select a suitable fixture according to the tab structure. If you are testing and balance maintaining the battery pack without undisassembly, then use a alligator clip to clamp the positive and negative poles of each string. After the batteries are connected, first check whether the corresponding channel has a voltage display on the software. If there is no voltage display, please check whether the probe or the clip is in good contact. After confirming that the channel connected to the battery has the voltage display, we select the corresponding channel, press and hold Ctrl. You can click on multiple channels to select at the same time. If you select channel 1 and press Shift, and then select 9, all channels 1 to 9 will be selected. Press Ctrl and A to select all. Then right-click to start, select the corresponding program name, and click OK to start the program. After the device is running, first check whether each channel has a current value display. If there is no current value, please check whether the probe shell is in good contact with the battery, and whether the two sides of the clip are in good contact with the battery. If the contact is good, please replace the testing cable to see if there is a problem with the cable. Right-click on a channel to view information about that channel and the work steps that are running. If you leave during the test and worries about an accident, you can click the pause button when leaving, and click the continue button to continue the test after coming back. Except the above two cases, click continue button, the machine will run the discharge at 5A current. After everything is displayed normally, start the program and wait for the program to complete. When the device is running, please make sure that the computer does not turn on the sleep state. If the computer enters the sleep state, the software will not be able to receive the data sent by the device, resulting in incomplete testing data. Next, we explain the test result view and data analysis. After all the steps are completed, if the matching program has been set, then we select all and right-click to select the Set Matching Program. The system will automatically match the results after dozens of seconds. Please be patient. If the channel comply with conditions, it will be marked tick, and if the conditions are not met, it will be marked cross. At the same time, there is also an information box here. The matching conditions and the corresponding values of each channel can be viewed. Click Export in the information box to export the matching results. Unmatched data will be marked in red in the Excel table for easy viewing. Also, you can right-click the channel to export the test data, enter the battery batch number, export this data and save it in an Excel file. The test report exported from here is the total data. If you need detailed data, you need to export it in the analysis, and we will explain it in the analysis. The meaning of this battery number refers to the date, batch number, cabinet number, device number, and channel number. Right-click the analysis in all selection state, and you can see the voltage, current, and capacity curves of all channels. You can compare the consistency of the batteries. If a curve is found to be very different, we can check which channel's curve is by checking and unchecking channels. After finding a channel with a large difference, we can single select the channel and right-click to analyze it to view the detailed data of this channel. Click the plus icon to expand the data, find the abnormal data to judge whether the battery is damaged and cannot be used. If the curve is smooth like this, then the battery is good. If there is an abnormal jagged shape, the inside of the battery may be damaged or unstable. If you find that the test result is very different from the ideal result, first check whether there are any missing steps in a single channel. If there are a few working steps or cycles missing, or there is no data for a certain period of time, after you expand the data of one step, then first check whether the computer is in standby. If the computer is automatically standby, turn off the automatic standby. When the computer is in standby mode, the software will not be able to receive data from the device. Secondly, check whether the network cable is in poor contact. At the same time, all the analysis data here can also be exported and saved in the table. The data exported from the analysis is detailed data, including each data uploaded according to the time interval. The data exported from the analysis is detailed data, including each data uploaded according to the time interval. This data is different from the data exported by clicking the right button of the channel. The data exported by clicking the right button of the channel is the master data. Record the total data of each work step. Click DCIR to view the internal resistance value tested. This value is not an accurate value. It is only for consistency comparison between each other. The principle of our capacity tester is different from that of the internal resistance meter. To get the actual internal resistance value, you should use a professional internal resistance meter. Right-click Match to cancel match. Click to enter the analysis interface. Click Import and select the folder of the corresponding model to import historical data for viewing. When the work program of a channel is completed, a data file will be generated. For example, the data file 001 here refers to the data file of latest running in channel 1 of device 0 and cabinet 0. The files below this file starting with 001 are the historical data files for this channel. The meaning of this file is the data of cabinet 0, device 0, channel 1 that started operation at 14:46:02 on February the 24th, 22. Select the data file you want to view to open. Here you can also export the data to save. You can also import multiple pieces of data for analysis and export reports to save. The above are all software operations and precautions of DT50W. Thank you for watching.
DK